Dear students, good evening and a warm welcome to CSAT Made 2025 series, where we discuss the most exam specific questions and concepts from the angle of your CSAT paper of 25. And our today's topic of discussion would be permutation. I am Sachin Gopanad. Actually, this topic I had planned for a further video. However, owing to a request from some YouTube comment, I have brought it forward. So let's begin the class, where we will learn the concept of permutation and how to solve the questions on permutation. This is the first question. There are 6 students in a class. In how many different ways can all the students be arranged to stand in a row? Okay, let's understand what the question is asking us. There are 6 students. There are 6 students in a classroom and they are to be arranged to stand in a row. In how many different ways can we achieve it? How shall we make sense of this question? It is like this. Let the 6 students' names be A, B, C, D, E and F. Their names are A to F. Okay. Now we are to make them stand in a row. In how many different ways can we achieve that? What do they mean by different ways? It is like this. Let's consider this the first position and that the last position. First position, second position, third position, fourth position, fifth and sixth. So we have 6 positions, right? In the first position, we can make A to stand, then B, then C, D, E and F. This would be one way. Then we can do it another way. We can do B, A, C, D, E and F. This is a completely different second way. Even though the last 4 people remain the same in the same sequence, we change these two. So it is a completely different order. It is a completely different way from this one. Then we can also do B, C, D, A, E, F. Such way we can make a lot of number of changes. Actually, we can make hundreds of ways in which these 6 people can stand in a row. It looks like a very big number, but really it is we can arrange 6 people to stand in a row in hundreds of ways. But they are asking us the exact number. In how many ways can we achieve it? How do we do that? Since this is the first class of permutation in our series, I will just explain to you how to answer this question without any formula. Based on just the concept, we will be able to answer this question. Let's see how. How many places are there? There are 6 places, right? 6 positions. Yes. And we named them A to F, 6 names. In the first position, how many options do we have? Who can we make to stand in the first position? We can make A to stand, then we can make B to stand, then we can make C, D, E or F. So we have 6 options to fill the first position. We have 6 options. Okay. Then we made one of them stand here. Okay. Let it be A or let it be F, it doesn't matter. Okay. For our consideration, let's say we made F stand there. Okay. If we made F stand there, in the second position, how many options are we left with? We are left with only 5 options because F is already standing here. A, B, C, D and E, only 5 people are remaining who can stand here. So we have only 5 options for the second place. So let it be E. Now F is standing here and E is standing here and we are left with 4 more people and we have to fill the third position. How many options do we have to fill the third position? We have 4 options only. A, B, C and D, because F is here, E is here. So we have only 4 options to fill the third position. Now 3 persons are standing, so we need to fill 3 more positions using 3 more people. So here we will have 3 options, here we will have 2 options, and ultimately we will be left with only 1 person. So only 1 option for the last position. So this we can imagine by common sense, by intuition we can imagine this. Now just multiply the number of options. 6 options, 5 options, 4 options, 3 options, 2 options and 1 option. Just multiply all of them, and then that will give you the number of ways in which you can make these 6 students to stand. How much that would that be? 6 into 5, 30, 30 into 4, 120, 120 into 3, 360, 360 into 2, 720. So there are 720 different ways in which 6 students can be made to stand in a row. I already told you there are hundreds of ways. How many ways? 720 ways. It looks like a very big number for just 6 students, but it is true. Only 6 students, they can be made to stand in 720 different ways, all of them standing in a row. Okay. Now you understood this concept. Let's go to the next question where we will learn another concept. Same question, they have extended it a bit. There are 6 students in a class, 3 of whom are girls. So if 3 of whom they are girls, the other 3 must be boys. In how many different ways can all the students be arranged to stand in a row such that all the girls are always together? Okay. Now this, they made the question a bit more difficult, now. Now we know how to make 6 students stand in 6 positions, but now they want us to ensure that 3 of them who happen to be girls, all of them are together. How? It can be like this. The 3 of them, they can appear here, or they can appear here, or they can appear here or here. So there can be 6 possibilities in which all the girls are together. But how do we ensure that? How can we calculate it? That would be very tedious, right? We cannot actually imagine doing this. That one, it was easy. Okay. Now how can we imagine this? To do that, observe here. They are telling us that all the students, all the girls are always together. So these 3 positions, they are forming a block. These 3 positions, they are forming a block, and these 3 positions, they are forming a block, and these 3 positions, they are forming a block. So in all the 4 possibilities where they are to be together, we can consider them to be a single block. For example, if the names of the 3 girls are G1, G2 and G3, and the names of the 3 boys are B1, B2 and B3, we will have G1, G2, G3 together, right? Here they will be together, here they will be together, here they will be together, or here they will be together. So can we consider them as a single block, a single entity G? Now this is one entity, this is one entity, this is one entity, and together all 3 of them, we will consider them as a block, a single entity. Now we can solve this question. How? So instead of 6 positions, now we will imagine 4 positions. The block G, it can appear here, then there will be 3 more positions left for the 3 boys. Or the girls block, it can appear here, then 2 boys can stand here and here, and the 3rd boy can stand here. Or the block can appear here, and 2 boys can stand here and the 3rd boy there. Or the girls block, it can stand here, and we have 3 positions for 3 boys. It is same as this one. This arrangement and this arrangement, it is same. Here it was a block, 3 boys, so 3 boys block. Or here it was a block, one boy, two boys. So here if the block comes, one boy, two boys. So this and this, they are actually equivalent. So how can we answer this question? By considering all the girls to be a single block. Okay. And how many positions will we consider? We will consider that there are only 4 positions. Okay. Let's solve this one now. Okay. Now we will consider that there are only 4 positions and 4 entities to fill. 3 of the entities are a boy each, and the 4th entity, it happens to be a block of 3 girls. Okay. How many options do we have here to fill the first position? We have 4 options: boy 1, boy 2, boy 3, or the girls block. Anyone can come here. So we have 4 options for the first position. If one of the entity takes this position, how many options do we have for the second position? We have 3 options only. If one boy sits here, we are left with other 2 boys and 1 girls block, or if the girls block takes this position, we have 3 boys, so 3 options. So here we have 3 options, and here we have 2 options, and ultimately we will be left with only 1 option. So in how many ways can 3 boys and a girl and a block of girls can be made to stand such that all the girls are together? Thus to be 4 into 3, 12, 12 into 2, 24. However, there is one more tricky thing to make a note of here. What is it? Let's say that the girls stood here. Let's say that the girls stood here. No problem. B1, B2, B3. Okay. However, in this block, there are further 3 girls, right? G1, G2, G3. Yes. And actually there are actually 6 positions, but for our convenience, for our easy solving of the problem, we made it to look like 4 positions. But actually this one position, it actually signifies 3 positions. And in this one block position, there are actually 3 actual positions. This is a symbolic position of 3 actual positions. And here also these people can interchange, right? So it can be G1, G2, G3, or it can be G2, G1, G3, or G3, G2, G1, or G3, G1, G2. Such way they can change their positions internally inside the block, right? We need to take that one also into account. How do we do that? We will see, we consider this one as a block. Let's do an internal permutation calculation for internal arrangement calculation for this block. Inside that block, there will be 3 positions, and we have 3 girls. In the first position, any of the 3 girls can come, G1, G2, or G3, and once one of them has taken one position, we are left with 2 more girls to take the second positions, and if one took this position and another took this position, we are left with only 1 position for the third place, 1 option for the 3rd position. So inside the block we will have 6 arrangements, and this block, it can be here or here or here or here. Anywhere it goes, anywhere the block moves, it will have 6 internal variations within itself always. When such a thing happens, so when we consider the block to be a single entity, we got 24 ways, and internally inside the block there can be 6 internal ways. What we need to do is do a multiplication of those two, 24 into 6, because wherever this block goes, this block can be arranged in different in how many different ways. Consider this one as a single block. There are 24 different ways in which this block can be positioned, right? In all those 24 ways, there will be further 6 different ways. In, for example, take this G to be here, B1, B2, B3, they shall be fixed there. but still this single G block, it can create 6 variations. Then consider it in the second position. In the second position also it will take 6 different ways. So that way, if you can arrange this first arrangement, this bigger arrangement in 24 ways, in each of those 24 ways, it will create 6 more sub ways. So each of the 24 ways, they will have 6 sub ways. So ultimately, in how many total ways can you arrange 6 students, 3 of whom happen to be girls, such that all the girls are together would be 24 into 6, that would be 144. Done. Now we learnt 2 concepts from 2 questions. One was how to arrange 6 students in a row, that is 6 entities in 6 positions. Now again 6 entities in 6 positions, however 3 of those entities, they are always together. Okay, we learned 2 concepts. Let's learn a third concept. It is an extension of the same series of questions. There are 6 students in a class, 3 of whom are girls. In how many different ways can all the students be arranged to stand in a row such that all the 3 girls are not together even once? There is no restriction for only 2 girls being together. Okay. This question, it is further more complicated. In the previous question, they asked us all of them shall be together. Now they are asking us to separate them such that 2 of them can be together, but not all the 3 of them. How do we do this? This would be, to solve it directly, it would be very tedious. We need to put 2 of them together, or we need to separate all the 3 of them. So we will have multiple cases to take account of. However, there is a shortcut way of thinking this. How? What is the one condition that the question is excluding us from? That they are asking us to count all the ways, but they are asking us to exclude one particular condition. They are asking us to count the number of ways in which they can stand, excluding one case. Which is that case? When all the 3 girls are together. So what we can do is, we can consider this. This is the first question. In how many ways can 6 students stand in a row? 720. 3 of them be girls, 3 of them be boys, still no problem. They can stand in 720 ways. And in how many ways can we ensure that 3 of them boys, 3 of them girls, all the 3 girls are together? 144. Now in how many ways can they stand in a row such that the girls are not together, all the 3 girls are not together even once? That would be 720 minus 144. Because what is this 720? We learnt it in the first question that we can make 6 students stand in a row in 720 ways. What is this 144? 144 is the number of ways in which 6 students can be made to stand in a row such that 3 of whom happen to be girls, they are always together. Now they are asking us to count the number of ways in which the girls are never together. All the 3 girls are never together. 2 of them they can be together. All the 3 girls, they are never together. So this 144 represents that, that's right. So if we subtract this condition from the total number of conditions, we will get the exclusion condition. What are they asking us to exclude? They are asking us to exclude the cases in which all the 3 girls are together. So 720 minus 144, that will satisfy the exclusion condition given in the question. That would be how much? 700 minus 100, 600, 580, 576. Yes. So there are 576 ways in which 6 students, of whom 3 happen to be girls and 3 happen to be boys, can be made to stand such that all the 3 girls are never together. 2 of them they can be together, all the 3 they are never together. How many ways? 576 ways. Okay. Now you learnt 3 concepts through 3 questions. Based on this, you shall be able to answer the next question, which would be your homework question, and it was asked in the 17 paper. I think it was asked in 2017. I'm not sure. I think it was 17, not 23. Okay. If two boys and two girls are arranged in a row so that the girls are not next to each other, then how many possible arrangements are there? Okay. Here we talked about 6 students where 3 were girls and 3 were boys. Here there are 4 people, 2 boys and 2 girls. They are asking us to calculate that 2 girls were not together. So how will you solve this? First solve for the 4 people. How many in how many ways 4 people can stand in a row? Then after that calculate the number of ways in which 2 girls are always together. Then do the first one minus second one. That will give you the answer in which the girls are never next to each other. Girls are next to each other, they are always together because there are only 2 girls. If they are together, if they are next to each other, they both mean the same. This will be your homework question. Do answer this and leave your answers in the comment section. We will answer this one in the next class. Okay. And now it's time to answer the question of your previous classes homework question. This was your previous classes homework question. Passages. Let's read the passage. There is a claim that organic farming is inherently safer and healthier. The reality is that because organic farming industry is still young and not well regulated in India, farmers and consumers alike are not only confused about what products are best for them, but sometimes use products in ways that could harm them as well. For example, since organic fertilizers are difficult to obtain on a large scale in India, farmers often use farmyard manure which may contain toxic chemicals and heavy metals. Certain plant sprays such as datura flower and leaf sprays have an element called atropine. If it is not applied in the right dose, it can act on the nervous system of the consumer. Unfortunately, how much and when to use it are not well researched or regulated issues. Okay. This is the passage and we have underlined the key terms. Let's read the options now. Which one of the following reflects the most logical, rational and practical message conveyed by the author of the passage? In organic farming, farming should not be promoted as a substitute for conventional farming. There are no safe organic alternatives to chemical fertilizers. In India, farmers need to be guided and helped to make their organic farming sustainable. The aim of organic farming should not be to generate huge profits, as there is still no global market for its products. Okay. How do we solve this one? I had told you that option elimination method is the best method to solve passage questions, and before going to option elimination we need to make note of key terms and then we need to make note of the tone of the passage. Okay. What are the underlined terms? Claims about organic farming. The claim about organic farming, what is the claim? It is inherently safer. Then but what is the reality? The reality is now is that it is not well regulated in India because there is a confusion among both farmers and consumers. Then sometimes it can be harmful, and farmers, they sometimes use farmyard manure which will have chemicals and fertilizers, and they use leaf sprays which are not well regulated and they don't know how much of it to use, and how much of it to use, it is not well researched either. This is the key terms and key content of the passage. Then after reading the options, we will compare the content given in the option with the content of the passage and the tone of the options to the tone of the passage. Okay. Look at the first one. In India, organic farming should not be promoted as a substitute for conventional farming. But does the passage talk about promotion? No, right? Promotion of it. There is no mention of promotion of organic farming at all. So we will eliminate option 1. Okay, because it was not in agreement with the passage at all. Look at the second one. There are no safe organic alternatives to chemical fertilizers. Okay. Now this seems to say that organic alternatives are not safe, but the passage does not say that organic products are not safe. It says that because of lack of regulation and because of lack of education and knowledge, the usage of organic products, it has become unsafe. But it does not say that chemical fertilizers, they are safer than organic alternatives. This implies that, this option, it would imply that chemical fertilizers, they would be safer than their organic counterparts. However, that is not the case. And the passage, it does not talk about harms of organic alternative. It doesn't say that organic farming and organic products are harmful. It only says that they are not, they are sometimes harmful because of lack of education among farmers and consumers and lack of regulation by the authority or the state. So we will reject this one also, because it is not in agreement with the, either the content or the tone. Okay. Why have I made this table? Because in the previous class I told you that I had given you, I think, 3 or 4 steps to do optional elimination. First one was to eliminate illogical, irrational and extreme options. Then to eliminate the options which are not in agreement with the content of the passage. Then to eliminate the options which are not in agreement with the tone of the passage. And ultimately, if you are left with 2 options, then eliminate the less appropriate one. Okay. Now we eliminated 2 of these options using this method. Then in India, farmers need to be guided and helped to make their organic farming sustainable. Okay. This is a very good option. However, we will not mark it as an answer until we have read the last one also. The aim of organic farming should not be to generate huge profits, as there is still no global market for its products. Is there any talk about products or global market of organic farming? No, right? So last option, it is not in agreement with the passage at all, or it is talking something irrelevant. It is talking irrelevant, and the first option, it is also talking irrelevant. Promotion, global market, profits. So first option and fourth option, they are actually irrelevant. Then the second option, it is not in agreement with the tone of the passage. The tone of the passage, it does not say that organic farming or organic products are safe. No, it says that they are sometimes safe because of lack of regulation, lack of education. So we will reject the second option also, first and fourth one also. So ultimately we are left with the third option, and we do not have any strong reason to reject it. So that will be our answer. Okay. I hope that you enjoyed today's class. I hope that it was beneficial to you. If you like the class, do watch us regularly. We upload 1 episode every evening. Then do share the YouTube link to the video to your friends through WhatsApp groups and Telegram groups. I wish you all the best, and most of all, I wish you a very happy study.